question, given the covariance between two random variables x and y is expected value of x minus expected value of x, y minus expected value y, and you want to show we can rewrite it in this form as expected value of x, y minus expected value of x times expected value y. So we want to go from this form to this form. So let's first write down what are we given the definition of covariance. Covariance between x and y is expected value of x minus, instead of expected value of x, I'm writing mu of x for expected value of x, and instead of y, I'm writing mu of y. It will just make the notation easier, right? So this is just a notational convenience that I am writing mu of x is expected value of x, and we know this is a constant because we know when you take expectation random variable, we get a constant. Mu of y is just expected value y, and this is also a constant because when you take the expectation of a random variable, you get a constant, right? So this is just notational convenience that the written expected value of x is mu of x and expected value y is mu of y. Now what we're going to do is we will first expand now. We will first expand x minus mu of x, y minus mu of y. We're going to do that. We're going to first expand this, right? So we can write covariance between x and y is equal to expected value. So when you expand this, you multiply this x with y. So this becomes xy minus we multiply this with mu of y. So this becomes mu of x. Then you multiply this mu of x with y minus mu of xy. By this mu of x with mu of y minus plus mu of x mu of y, right? So we just expanded this. You multiplied x with y and mu of y, mu of x with y and mu of y. So like this, we've expanded this, right? Right. So now we're going to use the fact that expectation is a linear operator. Now here we need to recall what do we mean by linearity. Let's just quickly recall that first. So when we say that expectation is a linear operator, what do we mean? So we mean linearity means that the expectation operator can go inside summations, which means that expected value sum is sum of expected value, right? So you can take it inside the summation. Linearity means that the expectation operator can go inside summations and constant multiples can come out. Essentially, by this we essentially mean it can go inside summations. So that just essentially means if we had expected value of x plus y, we can just write this as expected value of x plus expected value of y, right? It can go inside summations, right? Expected value sum is just sum of expectation. Constant multiples can come out. Essentially means if we had expected value of a of ax, where a is a constant, we can take it outside of the expectation operator. This is what we mean, right? So let's apply this linearity property here. And we know expectation can go inside summation. So expectation of sum is sum of expectation. Right, so I can write this as expected value of xy minus expected value of mu of yx minus expected value mu of xy plus expected value of mu of x mu y, right? So here we're essentially applying the property that expectation can go inside summation. Expectation of sum is sum of expectation, right? We're using the fact expectation is a linear operator. Although instead of a sum, we have minus here, but you can still think about it similarly. Because basically, if we were to write this like just, we could have written this as plus minus mu of yx, then expectation of sum becomes sum of expectation, right? And then constant multiples can come out, so the constant multiple minus 1 could come out. So you could apply linearity like this also, thinking in this terms. So applying the fact that expectation is a linear operator, that which means that expectation can go inside sums and constant multiples can come out. Now something to note over here very important is, now let's look at this mu of y, right? Now we know mu of y is a constant. We know we already established this is expected value y, which is a constant. So when you take expectation random variable, you get a constant. It's a constant. So we can take it outside expectation as well, right? You can take it outside expectation as well. Similarly, mu of x is a constant. Mu of x is a constant, so we can take it outside expectation as well. So we can take it outside expectation as well. Right now we're here, we need to see what mu of x, mu of y is. Now, mu of x and mu of y are constants. Now, both of them are constants. We've already established the expected values of x and y respectively are constants. Constant, so their product is also a constant. Right, if mu x and mu y individually constants, the product mu x times mu y is also a constant. And we know expected value of constant is just the constant, right? So we said mu of x is a constant, mu of y is a constant, the product is a constant. And expected value, the constant is equal to the constant itself. So the result of this is just mu of x times mu y, right? So over here what we're going to do is we're going to use the fact that mu of x and mu of y are constants. So we know, okay, we can take constants, we can take constant multiples outside of the expectation operator because expectation is a linear operator, so we can write it like this. We can take this mu of x out also, so this becomes expected value y. And we know mu of x is a constant and mu of y is a constant, so the product mu of x times mu of y is a constant, and expectation of a constant is just equal to the constant. Here that constant is mu of x times mu of y. Now one more thing that we're going to do is we are going to recall that we took recall. Here we're just going to recall we took mu of x to be expected value of x, right? This is what for notational convenience we wrote expected value of mu of x, and we wrote expected value y is mu of y. So let's just replace this back with expected value y, expected value of x like we did over. So now once you do that, right? Um, So let me just clear all of this up. So let's just clear it up, right? So what we're going to do is we're going to rewrite mu of x is expected value of x, mu of y is expected value y, right? So then, covariance between x and y will just be expected value of xy minus expected value y, expected value of x instead of mu of y. We just written expected value y because that's what we took mu y to be, right? We just rewrote expected value y as mu y for notational convenience, right? So and inside of mu of x, I'm writing expected value of x and then y, and then over here also, instead of mu of x, writing expected value of x instead of mu y expected value. Now we just simplify this. So now we can see this minus and this plus gets cancelled out. So then this becomes covariance between x and y, expected value of xy minus expected value of x times expected value y. So we have proven that we can write, we've shown that we can write covariance in the covariance between x and y in terms of expected value of xy minus expected value of x times expected value of y.